Right, so our third and final rock type, metamorphic rocks. Remember that all rocks are classified based on the environment in which they form. So, for example, we talked about igneous rocks resulting from the cooling and solidification of magma and lava. We talked about sedimentary rocks, which are typically formed in aquatic ecosystems where you have sediments being laid out, dropped by a depositional system, and then over time they are compacted and cemented together through the process of lithification. So our third and final rock type is basically a rock that forms from another rock. We call these metamorphic rocks, and these are rocks that form as a result of either really two mechanisms, one being heat and the other being pressure. Now, each of those can work in conjunction with each other or by themselves as well. So, a metamorphic rock is any rock that basically changes form as a result of heat and pressure. And as a result of these two mechanisms, heat and pressure, minerals have a tendency to recombine and reconstitute themselves to form new minerals, and therefore you get a new rock. Now, it's important to note that, yeah, we're going to be adding lots of heat, lots of pressure, but no melting can occur with metamorphic rocks. The moment it melts, well, then you already have magma, and once you have magma, that magma then cools and solidifies, and of course, then you're talking about an igneous rock. So metamorphic rocks are really heat and pressure added just about to the threshold of them melting so that they can reconstitute, but no melting occurs. There are two different types or two different occurrences in which metamorphism can occur. One that we call regional metamorphism, and the other is known as contact metamorphism. When we talk about regional metamorphism, we're talking about fairly large areas where some pretty amazing forces are occurring. Typically, mountain building events or tectonic activity is occurring when two lithospheric plates, collide. And as a result of these collisions, there's intense deformation or a sort of a destruction to the original structure, the structural integrity of the original rocks. And as a result, you get regional metamorphic rocks. So typically on geologic maps, they are indicated by these wavy rock structures as a result of compressional forces. Recall that sedimentary rocks are typically deposited in horizontal layers. Well, when those horizontal layers are compressed, you get this intense banding or deformation of the rock structure, and as a result the symbology looks the way it does here with regional. So regional implies that there is both heat and pressure occurring, typically at depth as a result of tectonic activity. Now, on the other hand, we can also get contact metamorphism. And now contact metamorphism is just heat alone. So this occurs when in very specific geographic localities where you actually have an intrusion of magma pushing its way through the rock structures. Now, obviously that magma is liquefied, and that's going to cool and solidify to become igneous rock. But the contact area, the interface, the boundary between the igneous intrusion and the surrounding, in this particular case, sedimentary rock, you have rock that's being superheated. And as a result of those high temperatures, the minerals reconstitute themselves to form contact metamorphic rocks. So here's actually a picture of the rock gneiss, and that's spelled Gneiss, and this is sort of your classic banded, what we call foliated metamorphic rock. So this is a result of intense regional metamorphism of both heat and pressure, commonly found in mountainous areas. For example, the Adirondacks, you'll find lots of gneiss. And what you're looking at here is a highly deformed rock structure, where originally you can see the black mica crystals and the black minerals of mica, as well as the white quartz. Now, you know metamorphism has occurred when you start to see a deformed nature to those minerals, where they actually become aligned. And that's what foliation means, or to have a foliated texture. It means mineral alignment. And as a result, if you can imagine, if you have like a piece of Play-Doh sort of in between your hands and you squeeze it, well, that Play-Doh is going to be compressed and then sort of follow that compression in terms of how it spreads out. Well, that's what's happening here with the minerals. The mica, the quartz, they're all being realigned as a result of a distinctive compressional force that has deformed the rock itself. Our final image here, yeah, okay, so this isn't the most brilliant image you've ever seen. This is the rock marble, of course. Marble is a metamorphic version of limestone. And recall limestone is a sedimentary rock. Well, if limestone comes into contact with intense heat as a result of a magma plume pushing its way up through the rock strata, it can actually burn it. And when it burns it, it realigns the mineral structure to form a metamorphic version of that limestone, which we know is marble. So that is it for Metamorphic Rocks, guys, and we will see you guys later.